So today we're going to look at how to name organic compounds. So this is a very simplified and a shortcut way, and the kind of the best way to do it and the approach. So first of all, there are millions of organic molecules we have. So the method we use is the IUPAC nomenclature, nomenclature. So to name this molecule. So first of all, uh, to name any organic compounds, we can break down the naming thing into three parts. So first of all is the locant. That's not important. Like some first part is the prefix, but some people sometimes you can consider locant as the first part because the locant is the numbers that shows the position of the side chains or the position of that specific group. So first of all, we have the prefix. So prefix is the first part of the name. So first of all, prefix can be uh, sometimes there can be no prefix at all. So a prefix can only be the prefix can be the stem. I mean the prefix could be the stem. Like there could be no prefix at all. So the first is it can be the stem. Like so it has 1, 2, 3, 4, and it's an alkane. So it's a butane. So we can see the uh, so we'll come about prefix being the stem later. So first of all, the prefix can be side chains. So for instance, alkyl. So this is a butanol, and no, this is an butane. This is a butane. So for we can convert this into it has 1, 2, 3 carbons. So 1, 2, 3 carbon. But let's put the last carbon into this. So the CH3, let's put it here. So what happens is, uh, so now the main chain, the longest chain that we have is of 3 carbons. So this is a propane. This is a propane. But now the thing that you can put forward in front, the prefix is going to be the alkyl group. So this is the alkyl group. So this is of one carbon. So we can say this is a methyl. So it's a methyl propane. And as I said before, before prefix, you can also say not the prefix is not the first part. It's a locant. So which shows the position of the side chain. So this side chain, the alkyl, it's in the second carbon. So you can say it's 2 methyl propane. So moving on, we see that for the naming, we put the any alkyl group first, any alkyl group or any kind of group. So it could also be like this that for instance you could have like this instead of butane, let's say you have 1, 2, 3, 4, 5, 6. You have six hexane. You had hexane, and uh, if you convert it, you can have a structural isomer. You could have a chain isomer as like this. You had 3 here, and let's say you had 4 here, and you could also have so 1, 2, 3, 4, 5, 6. So it could be this also. So you could say that you get for you. So first, what you have to do is that you have to choose from which direction do you want to count the carbon. So the law or the so in chemistry, what we do is we take the shortest route to the functional group or shortest route to the alkyl. So in here, if you the shortest route could be this and this in the same time, because they're the same group. So the shortest route to this group is from here. So you can say 1 2. So it could be 2 methyl, but as we can see, it's there is 2 methyl. So not only there is the position is 2, we have 2 methyl as well. So it's 2 dimethyl. Oh, it's actually 2 3 dimethyl. Actually, it's 2 3 dimethyl, because first we have this. If we consider counting carbon from this side, this direction. So this is first carbon, this is the second carbon, and this is the third carbon. So for the second carbon we have 2, and for the third carbon we have 3, and for having 2 methyl group we say dimethyl. So it's 2 dimethyl, and 1 2 3 4. The long chain consists of the main branch consists of 4 carbons, so 2 dimethyl butane. So what we see is, first is the locant. Second is the prefix, which is the other groups, or which is the other functional groups we will see later. And third we have no, second part of the prefix is that it could be side chains as well as it could be the other functional group. So what I mean by other functional group is that, for instance, let's say mm, so why is this? Let's create a new whiteboard, as that's creating a problem. So let's say we have a ketone. So we have bute. For 4 carbons we have bute, and for ketone, also for aldehyde, we have al. So it's butan al. But for instance, you have extra OH here. Somehow we have reacted in such a way that hydrogen is replaced by OH is replaced by like it has substituted the H. So you can call this as, so you can put this extra functional group to represent this extra functional group. What you can do is you can put it in the front. So you can just write it here, hydroxy butanol. Do you understand? So you can write a position in front. So if you consider as this is the main functional group, so this will be the first carbon, and moving on we have second and third, so it's going to be 3 hydroxyl butane all. Similarly, so we see that any other containing, so this could be a side chain, for instance alkyl, but this time this was not an alkyl, but this time this was an other functional group. So we just, to represent that, we just added in front of the name. And so so this could be, firstly this could be one, a side chain, second this could be an other functional group, or third this could be a halogen. So you know, like how we represent halogen or alkane. So what we do is, that we we have a butane, and this H was here, and let's say uh, mm, so this was full of hydrogens. Yeah, it was surrounded by hydrogen. Let's say you put a Cl here instead of one hydrogen. So how do you represent, or how do you name this? So you just write it like it was 1, 2, 3, 4. So it's butane, but in front, because of this, how do you represent this extra functional group? So as I said, this must be in the prefix. So you can write chloro, chlorobutane. And as this is like now, if you want to put the position, like if you want to, let's say, write the locant, so what you can do is, uh, as this is an alkane, there is no special functional group, and it's only single carbon, single bond. So you can just consider this the shortest route to this positional, and this functional group is from here. So you can just write 1 chlorobutane. So that is how you name the prefix. Now let's come to the second part, which is the butane. So that is the stem. So first what you do is this specifies the number of carbon. So this was an alkane. It contains single bond. It had no double bond. So for that it is ane. So it is an alkane. So the name ane at the last. But for it containing 1, 2, 3, 4 carbons, you get the name but. Similarly, for 1 carbon you have meth, 2 eth, 3 prop, 4 but. For 5 carbons you have pent. That's how you name it. For if you have it, so that is the stem. You count the number of. So usually we don't have the prefix. Like not always you have a Cl or a alkyl group attached. Not always that is the case. You just usually have a, this. Uh, that is the like the normal, like you don't have any branched or even any methyl group or any alkyl group attached to it, and you don't have any other functional group or any kind of other things. So you just can directly write the stem here like 1, 2, 3, 4. So you have 1, 2, 3, 4, 4 carbons, 1, 2, 3, 4. So you have but, that's called but, and it has only single bond, so this is an alkane. So the last part ane here, so it's butane. That's easy. Now moving on. So this was the stem, this part but, and the last part suffix is the functional group. So this could be butane, and if you had an OH over here instead of H, if you had an OH, so this would be an alcohol. So your first task was to see any branched or any. So your step 1 is to see whether there is any branches or any alkyl group attached. So as there is no alkyl group, your second task would be to count the number of carbon atoms, the stem. So it's but, and your last step would be to see what's the main functional group. So it's an alcohol here for OH. So it's butanol. So another thing which confused me when I was a student, I mean when I was doing my AS, that was that uh, in this stem, like this is not butol, instead this is butanol. So this ane comes from the types of bond you have. So usually what we see is you have single bonds here, right? So for it having single bonds, it's the name. So for instance, for having one atom, for one having one carbon atom, you have the name meth, and for having C single bond, you have ane, and for having C triple bonds, we have in, right? So whether though it falls in the suffix part, which is the which depends on the functional group, you can just but that still sometimes gets into the stem part, when you have something other than alkane or alkene, like alcohol, still you have to repeat the same thing, like ane. So it's butane because it has single bonds and all. So you don't have to worry about this thing so much. You just have to consider but and all. That is the main thing. So moving on, first we have this. So that is how we do. Like if we do a revision, uh, I think we have many examples for the revision. So let's do a revision for this. Like for if you have one carbon, you write meth. Similarly, for 2 carbon, eth, prop, but, pent. For 5 and for 6, you write hex. For 7, hept. For 8, you have oct. And for instance, you have oct. You have for instance, you have eth. For eth, you have two carbons, and you have OH group. So this is the suffix. So what you do is for 2 carbon, you write meth, methan, and for OH, you write all. So it's methanol. And in this carbon, like if you have an alkyl chain or if you have something of a chain, then that's what you put in the front. Like if you have a chlorine here or any kind of a functional group, then you're going to write, so this is going to be 1 chloro. So this is going to be 1 chloro. And now let's say we have a OH also over here. No, let's say you have so this would be fine. So 1 chloromethanol. So you get the point. Like you write the other functional groups or the other things here or in each other chains here, and the main thing goes at the end. Moving on, let's look at this. So our first step is to see whether there is any alkyl group. So there is no alkyl group. And so moving on, we have 2 carbons, 1 2. So it's eth, and this is an alkane because this contains single bonds. So the stem eth. So this one we haven't found any prefix, so we move on to stem. So it's an eth because it contains 2 carbon. And last we see what is the homologous series. So what is which group it belongs to, like what's the family of the group. So it's an alkane, it contains single bond, so it ends with ane. Moving on, here we have no branches or we don't have any other functional groups, so there is no prefix. Then we count the carbon numbers 1 2 3. So it's prop. We see a double bond, which means it's an alkene, so the name ene comes here, so it's a propene. And that's how we end. Moving on. Oh, so let's have a revision back there. So let's say you have a single bond, so you write methane. If you had a single bonds, means it's an alkene, so you end the name with methane, ethane, propane. But for you having double bonds, you name it ene. But why have I come here again? Like I wanted to show you what if you had 2 carbon double bonds. So like for instance, you had butane, so you had 1 2 3 4 carbons. But rather than having 1 double bonds, what if you had 2 double bonds? So 2 means di means 2, and in is in. Similarly, if you had three double bonds, you could write tri in. So for double bonds you have in, for 1 or 2 you have di or tri. Now let's say you have butane, but this time you have in one of the 2 carbons you have three bonds. So what do you name this functional group? This is the uh, so this is the alkyl. This is the alkyl group. So this ends in yn. So that is the thing here. So first we see there is no prefix. Moving on, we count the 1 2 carbon numbers. So 1 2 3 4. So we have 4 carbons. So the name but. Now we see the functional group, which is it has a double bond, so it is an alkene. so the name ene. However, it has two of this alkene, two of this double bond, so it's diene. So it's but-diene. Moving on. So moving on to, oh, we didn't write the uh, locant here. So in prefix, whether as there is no prefix, however, we have locations where the double bonds is situated in. So we have to show like the I mean where where the double bonds lie in, or where the functional group lies in the carbon. So you do this by writing the locants or the numbers. So in here, as there it's a symmetrical kind of a compound. It is an alkane. However, we have a double bond here and a double bond here. So the problem is now, like, which carbon do you consider to be the first carbon? So if we had only this one, so the shortest route uh, to this group, or to this double bond, would be from this carbon. So we always choose the shortest route. So for instance, we might have a OH here. So the shortest route to this OH would be from this carbon. So we should be counting from this carbon. So it's 1, 2. However, what we say is that uh, this could be the shortest route as well. This could be the shortest route, and they're the same. So what we can do is we can count. We can just consider any of them to be the shortest one, and then do the math. So we have in the first carbon. Let's go through this way. This way. So this is the first carbon. So it's but 1. We have double bond in here. So it's in the first carbon. And also, if this is the first carbon, this will be the second, this is the third, and this is the fourth carbon. So again, we have the double bond in the third one. So it's 1 and 3, and it's in, but it has 2 of them, so it's diene. Moving on to the suffixes. So it's not that always you have alcohol or alkene or alkene. You might also have aldehydes, ketones, carboxylic acid. So how do they end in? So what do they end in? Like, so if you have one carbon, it's meth. So it's gonna be methanol. If you have one carbon, you can't have you can never have one carbon keton. You must always have at least a 3 carbon, because it must be in the middle. So let's say it has 3 carbons, so it's going to be pentanol. Not pentanol, propanol. Propanol. Propanon. Propanon. And for alcohol, it's, let's say we have 1 carbon, so it's going to be methan, and there is the ol. So that's how you do it. So let's look at this compound. Let me draw this compound. So we have butene, ol. So we have, this is the main compound, this is the main functional group. So 1, 2, we have but, so we have 1, 2, 3, 4, and this is the main functional group, which is the 1 ol. So let's say this is the first carbon. Let's just say this is the first carbon. This is the OH here, and others are surrounded by hydrogen. But later we see that we have we have a double bond here also. So in the second carbon, so let's say we have a double bond here. And also, if you move on the prefix, what we see as 2-chloro. So in the second bond, we also have a chlorine. So what we see is at front, we see, is there any side chains or any not the main, but the other functional groups or stuff. So we write it in the front. So moving on, let's name this. So what we say is 1, 2, 3. So we see there are 3 carbons. 1, 2, 3 carbons. So we can say it's prop. Now let's look at the functional group. So we have OOH. So this is going to be this is a carboxylic acid. So this is going to be double bonded to one O and single bonded to one OH. So this is going to be propanoic propanoic acid. However, we can there is no alkyl group attached, so there is nothing in front of propanoic acid, nor any other functional groups other than the carboxylic acid. So that's the name, propanoic acid. That's it. Moving on to the second compound, we have one. We don't have. We can't see any branches. Uh, it's just a straight chain with 1, 2, 3, 4, with 4 carbon. So we can instantly say that it's gonna be bute. So it's gonna be butan something. So we have, what we can see is we have oxygen here, double bonded, which means this is a ketone. So it's going to be butan on, and other than that there is nothing else. So what extra thing you can do is that the shortest route to the main functional group is from this side, and this is the first carbon, this is the second carbon. So you can write butan 2 on, like you can put the locant here. That is the extra thing you can do, but I don't think you have to do this. Moving on. So I think we're end with the we think we're done with the practice. We can do one more, so let's do this. So we have 1, 2, 3 carbon. So 3 means where is it? Let's do this, it's better. So we have 1, 2, 3, 4. 4 carbons, meaning it's a bute. And having single bonds, meaning it's a alkane. So it's butane. So we are done with it. And now let's look at the other things. So we see that we have side chains. These are the side chains. So now this side chains, which is the alkyl group, this alkyl, so it's the shortest route to this alkyl, or shortest route from the functional group actually. So let's say we don't have any functional group here, so shortest route would be this through this way, I mean this side. So this is the first carbon, this is the second carbon. So it's 2 methyl, and again we have 2, 1, 2 methyl. So we have this way also, this way also. So we have 2, 2. As we have 2 methyl, so we have dimethyl butane. So that's how easy it is to name a compound. Moving on to ring structures. So that is very easy as well.